Notes 3.4a are on solving rational equations. So the first three sections of our notes were on graphing rational equations and looking at the behaviors of the graphs. Now we're going to solve rational equations. For our notes here, there's a lot of room for question number 1. We don't need that much room, so don't write too big though, because we're going to add a question number 2 into our notes. Okay, so it says for number 1, it says to determine the point or points of intersection of the functions f of x equals 2 over x squared minus 1 and g of x equals x over x plus 1. Okay, so the first thing that I want to do is I want to find out what are some restrictions on each one of my functions. So that's the first thing I need to find. What are my restrictions? And the restrictions will happen when we have 0 in the denominator. So for f of x, to find my restrictions, I'm going to set the denominator, which is x squared minus 1, equal to 0. And then I'm going to solve it by factoring. This is a difference of perfect squares. So right here I end up getting x equals -1 and x equals +1 for x in order to get 0 in our denominator. So one restriction that we have is x cannot be -1, and then the other restriction that we have is x cannot be 1. Okay, now let's find our restrictions for g of x. Okay, so I'm going to set the denominator equal to 0 for g of x, which means x equals -1. So x cannot be -1, but it's already part of our restriction here. Okay, so now that we've done that, the next thing that we need to do is we need to find out what the point of intersection is going to be by setting f of x and g of x equal to each other. So our point of intersection happens when f of x is equal to g of x. Okay, so what I'm going to do is if f of x is 2 over x squared minus 1, I'm going to set that equal to what g of x is, which is x over x plus 1. Okay, so as always, we don't really know how to solve any type of equation unless it's linear, so we're going to try to make this as linear as we can. So the first thing I'm going to do is I'm going to get rid of my fractions. And in order to get rid of my fractions, I need to find an LCD. So this denominator here needs to get factored for me to find my LCD. So we already have it factored above, but we also know it's a difference of perfect squares. So right here, we've got x plus 1, x minus 1, and over here we've got x plus 1. So if you remember, to find our LCDs from last year when we were adding and subtracting rational expressions, we're going to try to find the least common multiple or the least common denominator. So we know that our multiple has to have an x plus 1 in it because there is an x plus 1 as part of both of my denominators. But because it's a multiple, I also have to include this x minus 1 right here. So that's going to be my LCD. So what I'm going to do now is I'm going to multiply both sides of my equation by my LCD. So I'm going to multiply this by x plus 1 times x minus 1. And whatever I do to one side of my equation, I have to do the exact same thing to the other side of my equation right here. So I end up getting right here, my x plus 1s are going to cancel out and my x minus 1s are going to cancel each other out on the left side. So I'm only left over with just a 2 on the left side. On the right side, the x plus 1 is going to cancel out with the x plus 1 here. So I'm left over with x times x minus 1. Okay, so now I'm going to solve this equation. This equation is so much easier to look at than the equation that we had up here. So I'm going to say 2 equals, distribute the x through, I end up getting x squared minus x. So now I need to get everything on one side. So I get 0 equals x squared minus x minus 2 right here. So that means that I end up getting 0 equals, I need to factor this in order to be able to solve it. So I've got x minus 2 times x plus 1, which means x equals 2 or x equals -1. But right here, we have a restriction saying that x is not allowed to be -1. So -1 is not one of my answers right here. So this is an extraneous solution. Okay, which means x equals 2 is the only place where my functions are going to intersect with each other. Okay, so now I know what the x value is that they're going to intersect at, but now I need to find the corresponding y value. So I need to find f of 2, or I need to find g of 2. And it's up to you, because you'll get the same answer no matter what, because the x values and the y values are going to be the same for our point of intersection. So I'm going to plug it into both just to double check to make sure I did this correctly. So if f of x equals 2 over x squared minus 1, I'm going to do 2 over 2 squared minus 1. So I end up getting 2 over 4 minus 1, which is 2/3. Okay? And then for g of 2, I'm going to do x over x plus 1, so it'll be 2 over 2 plus 1, or 2 over 3. So either way, we get that our y value is 2/3. So now all we need to say is, therefore, the point of intersection of f of x and g of x is at the coordinate 2, 2/3. And that's my final answer. Okay. Now we've done this algebraically, I just want to use Desmos to verify the answer. So I'm going to type in both of my functions. So my first function was f of x is equal to 2 over x squared minus 1. And then my other function is g of x is equal to x over x plus 1. Okay. And as I can see right here, when I zoom out, it doesn't appear to have any points of intersection except at, let me fix this, sorry, I'll fix this to x plus 1, there we go. So we see that we don't have any points of intersection except at 2, 0.667. Now it looks like it might intersect up here, but they won't, because they're approaching our asymptote of -1 right here, but they're approaching it at different rates, so they'll never actually intersect right here. So 2, 0.667 is our answer of 2, 2/3, so we're good to go for that question. Okay? All right, so please add question number 2 on to your paper, and the question is, what is the solution set of x over x minus 4 minus 1 over x plus 3 equals 28 over x squared minus x minus 12. Okay, so the first thing I'm going to do is I'm going to rewrite my equation with all of my denominators factored. So I've got x over x minus 4 minus 1 over x plus 3 equals 28 over, so I'm going to factor this x squared minus x minus 12. And when I factor it, it'll be x minus 4 times x plus 3. Okay? So now I want to figure out what my restrictions are. So for my restrictions, remember it's just where we'll have some undefined fractions. So x is not allowed to be 4. X is also not allowed to be -3. And then here, x is not allowed to be 4, and x is not allowed to be -3. Okay, so we've got our restrictions. The next thing I want to do is identify what my LCD is. So my LCD here is going to be x minus 4 times x plus 3. Okay, so I'm going to go through and multiply each term by this LCD right here. So I'm going to multiply this first one by x minus 4 times x plus 3. I'm going to multiply the second one by x minus 4 times x plus 3. And then I'm going to multiply this last one right here by x minus 4 times x plus 3. Okay? Now, when I do that right here, the x minus 4 and the x minus 4 in my first term will cancel out. So I'm left over with x times x plus 3. Okay? And then in my second term, the x plus 3's are going to cancel out. So I'm left over with -1 times x minus 4. okay? And then in my last one, the x minus 4 and the x plus 3 will cancel each other out. So all I have left over is just 28. Now that I've done that, all I have to do is just solve my equation that I have here. So I'm going to distribute this x, and I'm also going to distribute the negative. So I end up getting x squared plus 3x minus x plus 4 equals 28. So then when I collect my like terms right here, I get 2x plus 4 equals 28. I want to get everything together on one side. So I'm going to subtract the 28 from both sides. So I get minus 24 over here equals 0. Now I'm just going to factor and solve. So factors that multiply together to give me negative 24 but add up to give me 2 are positive 6 and negative 4. So x is equal to negative 6 or x is equal to 4. Okay? But let's take a look back at our restrictions again. X is not allowed to be 4, so again, we have another extraneous solution. Sometimes this happens, sometimes it doesn't. It's not always going to end up being extraneous, okay? So therefore, since it's asking us for the solution set, we're going to say the solution set is simply just negative 6. And that's my answer to this question. Okay, now after we learn the algebra for how to solve, we're going to actually use this to be able to solve several application questions to help us get those types of answers. They end up being rational equations, and now that we've done some practice, hopefully you'll be able to solve those types of equations after we learn how to set them up. Okay, that's it. Have a great day, and I will see you soon. Bye.